Okay, and I want to do that.
Slideshow.
That. There we go. All right, so Kestrel. So let's have a quick history of web servers in ASP.NET 5. We had Helios, which was our in-process, in-IIS hosting model. We had up until Beta 8. That is now deprecated, and we'll talk a little bit about that in just a minute. We have Web Listener, which is our managed wrapper around HTTP sys. HTTP sys is the kernel mode driver in Windows. It's part of Windows. It's not part of .NET. It's not part of IIS. It's part of Windows that provides a bunch of functionality, including obviously listening and terminating HTTP connections. Web Listener is a new managed wrapper around that. You can think of Web Listener as the spiritual successor to HTTP Listener. Who's ever used HTTP Listener in .NET? Okay, this is the spiritual successor. In fact, you can use Web Listener completely separately from ASP.NET 5. Okay, if you are using HTTP Listener today, Web Listener is intended to be a drop-in replacement. All right, and then we have a thin layer on top of that that lets it host ASP.NET 5 applications as well. That's one of the reasons Web Listener isn't going anywhere, okay, because it does replace HTTP Listener effectively. Then we have Kestrel, which is the new hotness. Kestrel is the new libuv-based cross-platform managed web server that the ASP.NET team is writing in order to help us help us do a bunch of things actually, but obviously one of those being making ASP.NET 5 run cross-platform. So why did we deprecate Helios? What was it about the way that Helios was an in-process hosting model in IIS that forced us to say, you know what, this is not working. We need to just reason about one server. Well, first of all, Helios was more than just a web server. It was its own host. It was a CLR host. So we have dnx.exe, soon to be the thing we talked about yesterday. dnx.exe, which actually boots the CLR. All right, we don't rely on the Windows booting logic. We do it ourselves. In Helios, we don't call dnx.exe. Right? It is in proc, in IIS, in W3WP, so we can't have another process. So we have to boot the CLR with a different host. Now, it's a lot of the same code, but it's also not, because it has to run in the existing IIS hosting infrastructure, which is based on system web. And so you can see that the second bullet point there is that in order to get Helios booting .NET, including .NET Core, we had to use a backdoor in system web to do it. So when you boot ASP.NET 5 in Helios in IIS, you actually boot old ASP.NET first, and then it creates 3 app domains, and then one of them will end up running the actual application. And if you've chosen Core CLR, it'll boot up the Core CLR next to the full CLR in the same process. So while it worked, it was less than ideal. And it was actually never the long-term plan. The long-term plan is that if we were going to continue doing the IIS hosting model, we would write a new IIS native module, and we would deprecate Helios. But we chose to do it a lot earlier for some reasons that I'm going into. Do we really need more than, do we really need 3 web servers? Having Web Listener, there's a concrete reason for Web Listener to exist, as I've already explained. It is the spiritual successor to HTTP Listener, and it does provide features via way of HTTP sys that some customers care about. Certainly not all. If you're on Linux, you don't give a flying hoot. And if you're on Windows and you don't care about things like port sharing, which if you're not running a web server that's multi-tenanted, where you have to be able to run lots of sites but share a single port, you don't care about those type of things. Okay? HTTP gives you that capability, but it also comes with some not so hot things as well, which we'll talk about. So we decided to sort of boil this down and say, you know what? We have Kestrel, which is the web server that our team is building that allows us to sort of our premium web hosting server for ASP.NET 5. And then we have Web Listener, which still allows you to get features from HTTP sys if you really need those features, while also being a successor to HTTP Listener for when you just want a really good HTTP self-host server that when you're not using ASP.NET 5, but still using .NET. So what is Kestrel and what is it not? So Kestrel is intended to be a production HTTP and HTTPS server for ASP.NET 5. And that's pretty much all it's intended to be. Okay? It is not intended to be a fully featured web server with all the bells and whistles and the alternate hosting models and all the configuration, all the protections that a fully featured web server gives you. Just like node.exe, which includes an HTTP server, isn't intended to be a fully featured web server. Okay, you can add stuff to Node by way of middleware, just like you could in ASP.NET to add more features. You can do that in ASP.NET 5. You can add static file middleware to do static file serving. Okay, even though Kestrel doesn't do static file serving, it's literally just an HTTP server. Or you can run it behind a fully featured, custom, built for that purpose web server, which is actually the recommended model. And that's in reality what practically every website on the public internet does anyway. There is almost always a layer in front of you, in front of the process actually running your application. In fact, if you're running in something like Azure, there are many, many, many layers in front of the process running your application that requests go through. And even when I used to work in government 10, 15 years ago, yeah, we had an IS server, IS 5 point whatever, and IS 6, but it wasn't the first thing that the web clients would hit. They generally hit like a Squid server or some big IP device or something else. Then it would go through to some load balancing tier, and then it would finally go off and hit IIS. So in reality, in practice, it's very rare that you actually hit your process running your app directly. Now, that doesn't mean you don't. There are scenarios where you do, just like sometimes you just run node.exe and you hit it, and that's fine for your environment. Kestrel is perfectly fine for that as well. Yes, we have a question already. So the question is it suitable for deployment to an Azure website? Yes, because this is the web server for ASP.NET 5. So if you want to run ASP.NET 5, you use Kestrel. Web Listener is only something you look at when you specifically need features that HTTP Sys gives you. When you deploy a Beta 8 website to Azure, it'll use this. Okay, it does use this already. In fact, as we'll look at in a minute, the IIS hosting model for Kestrel uses a module that was built for Azure. Okay, so Azure's been using this hosting model well before we decided to use it in Beta 8. Okay, and I'll get to that in just a minute. It is not intended to be a generic libuv.NET server. We've had a number of customers, a number of people on GitHub ask, can I just use Kestrel as a generic C# libuv wrapper, and can I add more protocols to it? And can I use it for UDP? And can I use it for XYZ? No, that's not the intention. We are not, as the ASP.NET team, trying to build a generic socket server or a generic network server using libuv that you can then do all this other stuff with that isn't an ASP.NET server. Libuv is an implementation detail of Kestrel. Yes?
What is libuv? You keep using that term.
I will get to that. That's the next slide, I think. It's not intended to be that. It is recommended that you run it behind a more fully featured web server, like I said. In Windows, that's generally going to be IIS. And on Linux, that will generally be something like Nginx, just like you would normally do if you're running a node server. You could run it behind anything that allows you to do process management, or you can manage the process yourself, and can obviously just reverse proxy requests from whatever your front-end server is to the actual process running your ASP.NET app. So what is libuv? Because I keep talking about libuv, and we talk about it a lot. Libuv is a cross-platform async I/O library. It's the same one that's used by Node.js. In fact, it was built in order to support Node.js, and then Microsoft, when we decided we were going to help make Node run really well on Windows, contributed development time to making libuv run really, really well on Windows. So what does it basically do? It essentially abstracts the various asynchronous I/O APIs at the lowest levels between Windows and the POSIX, and it wraps them in a shim so that you code against libuv, and then your I/O network file, etc., runs on Windows and on Linux and on Mac in hopefully the most efficient way possible. It's intended to be a very thin layer. It's actually very simple if you read the code and you know C++, which I don't. So I just trust other people. And it's extremely efficient. So it's a good choice. It means we don't have to, at the moment, worry about having a very robust cross-platform socket story that we build on top of. We can get going with libuv, and it's tested. It's used in Node, so we have that sort of coverage and that safety and number sort of vibe going on as well. It supports multiple architectures as well as multiple platforms. So x86, x64, and it also supports ARM. And as of last night, Pavel, I'm not sure if he's here yet, Pavel confirmed that the latest versions of libuv that we're now building work on Raspberry Pi for Windows 10 IoT Core. So you can now run Kestrel on Windows 10 IoT Core on a Raspberry Pi, because we're now compiling libuv from source as part of our build. So you can actually see, here's our GitHub repo where we actually compile libuv. This doesn't contain the libuv code. We take the libuv code from the libuv repo on GitHub, but we compile it against the right header files and reference assemblies and things so that it'll run on all the new versions of Windows, the 1 core, Nano, all those type of things, Windows 10 IoT Core, and obviously for OS X as well. Now, we only compile for Windows and OS X, and we put those in the Kestrel NuGet package. So if you're deploying to Windows and when you're using on Mac, all you have to think about is I reference the NuGet package for Kestrel and everything works. Linux is a little bit differently. It works a little bit differently. In Linux, the intent is that you need to compile libuv yourself and install it where you want to put it on the machine. Apparently, that's just the Linux way of doing things. Or you can use something like apt-get to get a pre-compiled version of libuv and do it that way. Libuv itself doesn't distribute a compiled version of libuv for Linux, which, again, I'm told is pretty normal in the Linux world. I'm not a Linux person, so I'm just going by what other people tell me. But generally, this is not uncommon at all, very similar to things like OpenSSL and those type of things. So we have instructions on how to do this on all the docs. There's basically a bunch of script that you run, which will get the source, compile it, and then install it into the, what's the folder, Glenn? What's the folder? Local bin, blah, 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 something, something. Someplace on Linux that makes sense, and links it. And then Kestrel, the .NET code, will load it from that location dynamically when the application is running. Some interesting notes on the architecture of Kestrel. So libuv uses a single-threaded event loop model, very similar to Node.js, which means that you basically just have one thread that's a Kestrel, that's a libuv thread, and it is the thing that's reading bytes off the wire and then dispatching into code that you write in order to hopefully be very efficient. Because we live in a multi-core world with lots of CPUs, though, Kestrel will spin up multiples of these loops under the covers so that we can support more I/O concurrently. Who's ever used node clustering? Everyone here? Yeah, okay, so a bunch of people. So a lot of the times now there's a node clustering module so that when you start node at the command line, your app can be configured to actually start multiple instances of node.exe so that you get a node.exe per core, effectively, because node is single-threaded as well. So this is a very similar model, except we do it in process. Rather than starting up multiple instances of DNX, we have one instance of DNX, and then we have multiple threads inside of it that are doing libuv work. We only do I/O work on the libuv event loops. So those threads that are doing all the libuv stuff in the libuv event loop, which is single-threaded, are only doing I/O work, are only reading bytes off the wire and sending bytes off the wire. All the other work, including everything to do with HTTP, framing, parsing, all that goodness, is all done in managed code, standard C#. It's a bit of p-invoke, but it's standard C#, on .NET worker threads. Okay, so we only need to do that farming out in order to get more concurrent I/O. But most of the actual heavy lifting is done on just standard .NET worker threads, which is good. It means it scales like .NET scales in multi-core environments. And this should be giving you an indication of the type of things that we can do in Kestrel that we just couldn't do in IIS. Like IIS, based on HTTP.sys, kernel mode driver in Windows, very, very good at what it does. But it's a closed box, and you only get a new one when Windows ships. Okay, so if you want a new feature that is HTTP specific, like HTTP 2, or WebSockets, anything like that, then you have to wait for a new version of Windows. Okay? And then we keep getting feedback like, why didn't you port X down level? Why can't I get WebSockets on Windows 7? Well, it's because it's implemented in HTTP/sys, and we don't ship parts of Windows down level like that. Okay? So the Kestrel architecture allows us more freedom as the ASP.NET team to build features into our web server at a more rapid pace. It also means that we can work on particular things like performance with a much more intent focus than we've been able to before, because we can architect for things like avoiding syscalls. In HTTP/sys, every time you want to read bytes off the wire or read HTTP things, you pay the cost of doing a syscall. With Kestrel, we can architect it such that all the I/O loops, which is where all the system code is happening, is reading stuff off the socket, is completely separate to the managed code that's running your application. And so we can optimize when that boundary is crossed to make it as minimal as possible so we can avoid the cost of doing syscalls. Yes?
Does it use I/O completion ports?
The question is, does it use I/O completion ports on Windows? Yes, it does. So libuv on Windows uses I/O completion ports for doing I/O polling and callback, and on Linux it uses epoll and KQ or whatever those things are called to do that. Yes, and so Kestrel uses I/O completion ports as a result. So for people who don't know, I/O completion ports are a mechanism in Windows that enables you to do asynchronous I/O. You say, read some bytes, please, from this file or from this network, and then when you're done, tell me via way of this I/O completion port. It's just a handle, say this thing, and then you go away, right? And then it's your job to go back at some point in the future and check that I/O completion port to see if work's done. It doesn't push it to you. Now, if you're a .NET developer and we talk about I/O completion ports, the assumption is that that kind of happens and then you get pushed the result. It actually doesn't. If you're down in Win32, you have to do the work to poll the I/O completion port. And that's why they talk about I/O threads. You generally create a thread in your app whose only job is to post I/O work and then poll I/O completion ports to get the outcome of that work. It's just that .NET does all that for you. All right? You don't have to see that. You just do stuff, and then the .NET thread pool manages a bunch of threads that do that work for you. Okay, that's why .NET is so nice. It does all this sort of stuff for you. Kestrel uses all that architecture. Long story is, good thread use. Asynchronous is good. So what are some of the features that we get in Kestrel? Well, HTTPS support just landed in Beta 8, but is currently only on .NET Framework. We're waiting for SSL Stream, the standard SSL Stream API, to be ported to .NET Core to light up on Linux. So we're using SSL Stream to get SSL support in Kestrel, because Kestrel has a feature that allows you to wrap any stream around the Kestrel stream. Okay, so it's a wrapper sort of stream API, which means that you can write your own stream wrappers, plug them into Kestrel to add whatever type of stream processing you want to the Kestrel input-output stream. Okay, really, really nice flexible API. We use that to add SSL support. We support opaque upgrade. This is the idea of client makes a web request to the server, okay, and then first it makes a TCP socket connection, and then it says here's an HTTP request, right? And then as part of that first request, it can send a special verb that says, I want to stop talking HTTP now. Let's just, now that we have an underlying socket, how about we just use the socket? Okay? So I used HTTP to negotiate that, but now that we've got that socket, how about we just party on the socket from now on? That's exactly what WebSockets is. WebSockets is a formalization of that idea. Opaque upgrade is a server feature that allows the application to say at any point when a request comes in, I'm going to take over the socket now, web server. It's not your job anymore. The client and I have negotiated via HTTP that we want to talk on sockets now. Just give me the raw stream. Give me bytes in and bytes out. So we support that in Kestrel. Why is that important? Because it means that we can add features to Kestrel, or the application can add, middleware can add features by just upgrading the underlying connection to a stream and then wrapping that whatever protocol that you like. Okay, it's really, really powerful. So we use that to enable WebSockets. We can also potentially use that to enable HTTP2 support, which we haven't got just yet, but it is planned for post V1. Okay, so HTTP2 support will give us connection multiplexing. Connection multiplexing simply means that when the client and the server establish a connection, they can now, rather than sending one HTTP request and then waiting for a response and then sending another request and waiting for a response, the client can send dozens of HTTP requests and the server, like simultaneously, concurrently, and the server can respond to those out of order. Okay? So who's heard of HTTP pipelining? Anyone heard of that? So that allows you today in HTTP 1.1 to send lots of requests before you get the response, but the responses must be sent back in order. Okay, so I can send 16 requests to the server and then I can stop while the server then sends me 16 responses in the same order that I sent the requests. That's pipelining. No major browser has pipelining turned on by default today. I think Opera tried, or Firefox tried at one point, and it broke too much stuff, so they turned it off. But the performance benefits are huge. But of course, if you're doing API development and you have clients that aren't browsers, you can use pipelining to great effect. Okay, so which is why a lot of benchmarks talk about pipelining and so other reasons we do that as well. HTTP2 is supported by all major browsers now, and it effectively gives you the benefits of pipelining plus some more. Because not only now do you have to, can you send them back in order, you can send them back out of order. Okay, so HTTP2 is real world benefits of pipelining. You can just send as many requests as you like, and you get back responses out of order. You can have lots of WebSockets going, multiplex on the same connection as well. Okay, it's really, 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 really good. It gets rid of that whole problem around, oh, I need to create 6 subdomains so that my client can create 6 different TCP connections because HTTP only lets me have 2 outstanding HTTP requests per socket, right? That all goes away with HTTP 2. Post v1. Unix sockets are also supported. So as well as supporting TCP sockets in Kestrel, if you're running Kestrel behind something like Nginx in Unix, using TCP between processes isn't the most efficient thing you can possibly do. It's still really good, but if you have 2 processes on the same box and you just want to communicate between them, there are generally more efficient things that you can do than sockets. Sockets works everywhere. So we support Unix sockets, which is kind of like named pipes on Windows, okay? So that when you're running behind Nginx, you can use Unix sockets between Nginx and Kestrel, and then Nginx is the one that terminates the TCP connection to the actual client, okay? It is possible that in the future we would support a similar model on Windows and maybe support name pipes or something between whatever you're running on Windows as the front end and Kestrel. So running with IIS. This is the big change that we made in Beta 8 as a result of the things I've talked about. We use a thing called the HTTP Platform Handler. It's an IIS module that was written by the Azure Websites team to host technologies in IIS in Azure that aren't in process in IIS. It means that every time a new technology stack like Node or Java or Ruby or PHP or any of those things comes out, they don't have to write another IIS module that can host it in proc, or they don't have to fall back to using FastCGI. Okay? What it allows you to do is basically turn IIS into a very simple reverse proxy. ARR, application request writing, has this full functionality today, but it's incredibly fully featured. If all you want to do is say, this website in IIS needs to start this process, because that's where the application is going to run, and then when that process starts, I want you just to proxy requests from IIS to here and back, and then if the process crashes, I want you to restart it, and if the process has environment variables you need to set, I want you to set them for it, and I want you to capture the standard out for that process and put it in a file so that we can log it. That type of application hosting is what this module does. And it's been used in Azure for a while now to support Java in Azure Web Apps, okay? And so this is not something we invented. This is something that's already exists in Azure. It's battle tested, and we're using it now to run Kestrel behind IIS, exactly the same way you would run Kestrel behind Nginx on Linux. So now we have a single hosting model for ASP.NET 5 that pretty much looks like the hosting model for every other web platform on the planet, which is good. Sometimes it's good to be different. Sometimes it's nice to be the same. So the question is this the one that runs the DNX web command? Yes. So what will happen is, well, we'll look at this in a minute. I'll just show you rather than talking to it. We have added some features to the HTTP Platform Handler. Previously, it was Windows 8 and above only. With HTTP Platform Handler 1.2, they've downported that to match the target Windows versions that ASP.NET 5 is running on. It also now supports forwarding Windows authentication. So you can configure IIS to do Windows auth, and then it will forward the Windows auth handle and inject it into the process, the DNX process, so that Kestrel and your ASP.NET app can still do Windows authentication, even though you're using Kestrel in here and IIS is separate. It'll also do the process management for you, just like W3WP does today, just like app pools do today. The app doesn't actually run until the first request comes in. So it's a lazy process start. Okay, first request comes in, process starts. It has timeouts, it monitors the process, it checks to see if it starts within the configured timeout. If it doesn't, it shuts it down, tries it again, logs all those details. If the process starts and has requests and then it stops for some reason, it'll try and restart it. And we're also working with the team, I think they've actually already done this. I don't know if someone's here confirmed this. I think we've already got the change in that enables the request draining feature. So you know how in ASP.NET previous, when you had an app running and it had requests in flight and then you dropped a new DLL in the bin folder, those requests would keep running with the old version, and then any new requests that came in would run with the new version of the app. That's called request draining. We drain the old requests on the old app, and then we fire up the new app simultaneously so that new requests go to that. We have the same feature being added to the HTTP Platform Handler, but instead of now being in proc with app domains, it's cross-process. So DNX.exe is running, it sends a notification to say it's shutting down. And so IIS stops forwarding new requests to it, but the ones that are already there just drain out and finish. IIS will immediately start a new process, queue up any new requests until that process is running, and then redirect all the new requests to the new process, and the old one will just go away when it's finished shutting down. So you have a nice seamless transition between two instances of DNX if you deploy a new version of your app. Okay, so we're getting all the same features that we got in IIS previously, but now it's out of proc using the same hosting model that we have everywhere. You can configure environment variables per app process, just in web.config. This is why web.config came back, by the way. Web.config came back in the templates because web.config is an IIS configuration file as well as being the ASP.NET 4x configuration file. In this case, we're just using it to configure IIS. There's only a system.web server. There's no system.web. And you can, sorry?
Do you still have an application host running?
So the question is, do we still have an application host running? What do you mean by that?
Well, you're starting a new process here, right? So,
Yep.
So is the application host still running in IIS?
You mean like W3WP?
Yeah.
Yes. So W3WP still runs. There's still an app pool, right? You can set the app pool to not have any managed code if you want to. You can set the CLR version to none because there's no managed code running in the app pool. It just proxies out. But you can leave the managed code on, and you could actually put a managed module or a managed handler in there and use URL rewrite and mapping and things to have some of your requests go to an old ASP.NET app and some of them to a new app. So I can tell you I have URL rewrite working, for example. URL rewrite just works. Okay, it's a native module in IIS. Live ASP.NET, which is now running on Beta 8, uses URL rewrite to do things like redirect from HTTP to HTTPS. That all still works because it still runs through the IIS request pipeline. The HTTP platform handler is just another IIS module. It's not a different hosting model in IIS. So you can still run all the IIS stuff, and then at the last second it goes out into Kestrel. Yes?
And where exactly the HTTP platform handler fits into the IIS event pipeline? It's module or handler or?
So the question is, where does the HTTP platform handler fit into the IIS request pipeline? So technically in IIS, you just have modules, and modules can become handlers if they choose to handle that particular event in the module lifecycle. Okay? It is just a module like anything else, and depending on how you configure it will determine where it runs. But effectively, it's designed to handle requests as a module, whereas URL rewrite is designed to handle requests and then rewrite them. And you can write that there are auth modules, the compression module, all those things still run in the pipeline. And you can, like I said, you could run, if you set the app pool to still run managed code, in theory, I haven't personally tried it yet, but I'm told this works. In theory, you can write a managed HTTP module, just like you could in ASP.NET, have that run, and then still have it then go out of process after that code is run off to your ASP.NET 5 application. Okay? It's just another module in the IIS pipeline. Okay, so it still works like IIS. We didn't invent a new hosting model in terms of IIS. Yep. So the question is, are we planning on doing anything with Apache? No, we are not as a team. If that's something that we hear lots of feedback about, we could certainly look at that. Certainly not going to happen for V1. For V1, it'll be IIS on Windows and Nginx on Linux, and we'll have guidance on how to set up Nginx on Linux to do hosting. But frankly, there's a lot of guidance already on how to set up Nginx to do hosting on Linux. But if Apache is something that people demand, then we could certainly look at that. Question, yes. Yep. Mm-hmm. So the question is, with regards to the NTLM double hop thing, does that play in here? The NTLM double hop, if I think back to my days of actually doing intranet development, the problem was when you try and do impersonation with Windows auth, and you then hop across two boundaries, it looks like it works, but you actually lose the handle on the other side. You don't get that problem here. What happens is IIS does the authentication for you using its built-in Windows authentication. It gets a handle, like an OS handle that represents the Windows principal, because that's how Windows auth works. Once the whole NTLM exchange has happened, and then when it forwards that request to DNX, it injects the handle into the process. Because it started the process, it can inject handles into its memory space, and then it forwards a header with a request that says this request is being identified by that handle by this ID that I injected into you. And then we have a piece of middleware that you may have seen in the Beta 8 templates, the app.use IIS integration, blah, 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 blah. That middleware knows how to read that header, strip it off the request, and then create you a Windows principal based on that handle. Okay, so we effectively do a secure injection because we own the process, inject that handle in, and then it's just a normal Windows handle at that point. It just got shared between, handed off one process into the other one. Yes?
How does Kestrel communicate with the platform handler?
So the question is, how does Kestrel communicate with the platform handler? It's just sockets. So right now, actually, it's HTTP. So what happens right now is you have W3WP that's running the HTTP platform handler. You have DNX that's running Kestrel. The platform handler is basically using WinHTTP, the Win32 HTTP client, to make HTTP requests over to here. That's what we'll ship for V1. The intent and the plan is that we could potentially improve that by having a raw socket be established between these two, and then just doing a much more efficient sort of binary-based byte shifting between the two. We could look at doing name pipes. Well, basically, I think we'll take it step by step and look at what's more efficient. In reality, in my performance testing with doing this type of model, you're never going to get, like, you never run benchmarks when you have two things in the pipeline. You just don't do that. Like when you're benchmarking an application platform, you benchmark the thing you want to get the speed of. When you do real world load testing, that's a totally different thing. That's not benchmarking, right? Benchmarking is a different practice to load testing an application. When I ran this architecture through our benchmarking rig, I was getting a little bit less than the raw throughput of an ASP.NET 4x application. So about 50,000, 55,000 requests per second when going via IIS and then hopping over to Kestrel. Now, if you are running a website that can do more than 50,000 requests per second, then you have all other types of problems. That's not going to be the one that you have. Okay.
Against straight Kestrel there.
Against how fast is straight Kestrel?
Well, in that same situation.
I'm glad you asked. I'm doing a whole talk on performance tomorrow, but I may as well peek if people haven't been following, and I can end with this because I'm over time. A standard ASP.NET 4.5 application using a stripped out configuration where we turn off all the modules that we don't want, using a plain text handler, can do on our rig up to about 60,000 requests per second. Kestrel currently just broke 500,000 requests per second for the same test. Okay. Now, we have a long way to go because Netty, which is based on Java and used everywhere, does 2.5 million requests per second on that same rig. So just to give...
recommendation to go get closer to the raw Kestrel performance if you have some sort of front-end upload.
That's a good question. It depends on, you have to ask yourself why at that point. Okay, we can talk about that offline. Again, I would challenge that almost nobody needs to do 50,000 requests per second in their actual application. MS.com, like Microsoft.com, is one of the biggest websites in the world. A couple of years ago at peak was doing about 35,000 requests per second across the entire farm. Now in peak situations today for social networking sites and things like that, yeah, those sites under bursty load need to handle a lot more than that, but they have entire multi-continent data centers contributing to that as well, to that type of load as well. So on one server, you generally don't need to be able to do that much throughput. All right, that was a quick overview of Kestrel. Glenn's next.